Left off yesterday talking about permutations. And in a permutation, if you recall, order does matter. Okay? Today we're going to talk about the other half, which is combinations. Okay? Combinations is a set of objects with no specific order. Okay, so here you'll hear me say order does not matter. With combinations, it's the number of combinations of our objects taken from a set of n objects. And notice we have a formula again. Okay, with the formula, NCR, very similar, other than there's an extra piece in the denominator, right? So you still have n factorial on top, you still have n minus r factorial on bottom, but you also have an r factorial. So we'll definitely talk about different ways, and another reason to really have the calculators in front of you to make sure you know what you're doing here. And then as I mentioned, the buttons, there are options to do these on the calculator at some point in time. I will definitely make sure to work that in, okay? But you still have to be able to show the steps to work depending on what is asked on the quiz. So, let's look at this first example here. Marisol is planning to be a counselor at summer camp. She can choose 3 activities for her session. And you'll notice on the screen there are a list of activities. And the question asks how many different combinations of 3 activities are possible. Now, they specifically use the word combinations. So they are upfront telling us, find the combinations, order does not matter. When we're asking her to choose 3 activities for her session, what they're saying is, does order matter of what order you do those activities in? No. Okay? So that's the scenario here. We're not trying to look at how many different arrangements she can pick, but just how many different groups of 3 are there, essentially. Okay? So, with that in mind, with combinations, you're going to see me go straight to the formula. Okay, this is not an easy one like with the permutations. We could also just set up so many things and so many blanks. Combinations, you're going to see me go straight to the formula. This is a combination of how many things are we picking from to fill how many spots. What do we know here? Picking from how many activities? 10 to fill how many spots? 3. So we're going to do 10C3. With a permutation, the first number always has to be larger or the same as the second number. It cannot be smaller, it's just not possible. On top, n factorial, which is the 10 factorial. On bottom, it's r factorial, which r factorial is 3 factorial. And then n minus r being 10 minus 3 factorial. If I clean that up a little bit, it's 10 factorial over 3 factorial times 7 factorial. Now, here's a little helpful hint. These 2 numbers in the denominator will always add up to be the number on top. So it's not a coincidence that 3 plus 7 is 10. That will always be true. Now, we can use a calculator to multiply these out. You can figure out how to do a factorial on your calculator and do that. I also, again, want to show the math behind it. What does 10 factorial mean again? Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All multiplied, of course. Okay, what does 3 factorial mean? Three times 2 times 1. And 7 factorial? 7, 6, 5, 4, 3, 2, 1. You guys were a lot chattier yesterday. What happened? We're not awake yet? Okay. Huh?
Thursday's the worst day.
Okay, I thought it was like Monday or Tuesday, but. Okay, guys. To avoid typing all this in on the calculator, what can I do?
Cancel
Can 7 through 1 cancel? Now, there's another set of canceling you can do. Okay, we didn't have this situation yesterday. What do we have left on bottom? 3, 2, 1. Okay, now, we could leave it as is and just do 10 times 9 times 8 divided by 3 times 2 times 1. That's not bad. But what about 3? Does anything on top divide by 3? 9. So go back to your reducing skills, canceling skills. 3 divided by 3 becomes 1. 9 divided by 3 could become a 3. So you can replace the 9 on top with a 3. What about 2? We have a 2 in the denominator. Does anything on top divide by 2? 10 or 8. Either or. Pick one. You don't get to do it twice. Just pick one. Okay? So if we say 10, then 2 divided by 2 is 1. 10 divided by 2 is 5. And the only other thing we have left is a 1. Does a 1 matter? No. You're dividing by 1. Multiplying by 1. It doesn't matter. So what does that end up that we're doing here? 5 times 3 times 8 is what? Okay. No. Notice I'm not arguing if you typed in all the numbers to begin with, or you found the factorial button on your calculator, if you found the combination button on your calculator. All those things will work. Okay? But I want you to know the setup, the process here as well. Okay, questions?
Where's the factorial button?
It's there.
Is it just
It's in the probability menu.
start at that?
I'll talk about later.
All right.
Okay? I will talk about later. Okay, B. How many ways can a camper choose 5 activities from the 10 available activities at the summer camp? What are we setting up here?
We just did the same thing with 5.
Okay. 10C5 instead of 10C3, yes? And again, it's choosing 5 activities. It's not arranging them, which would indicate order. It's choosing 5 activities. Okay, so do your setup. On top, n factorial, which is the first bigger number, 10 factorial. On bottom, remember your formula, r factorial, which is the second number, the 5. And then n minus r factorial, which is the 2 numbers subtracted, 10 minus 5 factorial. So, on top, 10 factorial. On bottom, 5 factorial times 5 factorial. Okay. 10 factorial means 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 5 factorial. 5, 4, 3, 2, 1. Another 5 factorial. 5, 4, 3, 2, 1. Now, I'm going to talk canceling again. Okay. On top, or what can cancel? Okay, so a 5, 4, 3, 2, 1 on bottom can cancel with the 5, 4, 3, 2, 1 on top. Now, as you look at the bottom, do you see anything that we can cancel with the top? What'd you say? 5 and 10? Now, if we actually want to do something, how do you get 10? 5 times 2. Do we have a 2? Could we say 5 times 2, which is 10, cancels with 10? We could use the 2. We could use the 2 with any of these numbers, okay? But here's an option, because if I would have done 5 and 10, this 10 would have become a 2. This 2 could cancel here, couldn't it? Okay. What about 4? 4 can cancel with 8. 4 divided by 4 is 1. 8 divided by 4 becomes 2. What about 3? 3 divided by 3 is 1, and Pick one, 9 or 6, right? It doesn't matter. Which one were you guys going? 9. 3 divided by 3 is 1. 9 divided by 3 is 3. And here's the deal. It doesn't matter, guys. So at my point, as I look at this, I have 3 times 2 times 7 times 6 left in on mine. You might have slightly different numbers, right? But here's the deal. It's got to multiply to be the same thing. What are we multiplying to be? 2. Okay. 252 options of ways she can pick 5. Okay. Are we seeing how the combination formula works? Okay. Continuing. Do we have what we need? I'm going to go with that's a yes. Okay. Some other combinations. On this section, we're going to look at 9C2 versus 9C7 and see what happens with these. So, 9C2. How do we set up 9C2?
9 factorial on top.
Okay.
2 factorial and parentheses 9 times 2.
Okay, good, thank you. Okay. On top, we know, well, I guess I usually clean it up, don't I? 9 factorial over 2 factorial times 7 factorial. Then, on top, I know 9 is 9, 8, 7, 6, 5, 4, 3, 2, 1. You're getting good practice here this morning, right? 2 factorial is 2 times 1. 7 factorial? 7, 6, 5, 4, 3, 2, 1. What cancels? 7, 6, 5, 4, 3, 2, 1. Could a 2 cancel? I'm left with a 2 times 1. 2 divided by 2 is 1, and 8 divided by 2 is 4. In my opinion, I just turned this into a problem that does not need a calculator at all. Okay. 9 times 4 is 36. Okay. 9C7. Are you working it out? Have you worked it out? 9C7 on top is still going to be 9 factorial. On bottom, r factorial is 7 factorial, and then 9 minus 7 factorial. 9 factorial over 7 factorial times 2 factorial. I say, we can work this all out, or we can shortcut ourselves. What are we noticing here?
Two bottom numbers belong to the
Yeah. This is identical to that, isn't it? They're both 9 factorials on top. Both bottom numbers are there. They're just in opposite order. Is the order going to matter? No, because it's still going to be the same numbers. So I'm going to save us a step. What's this going to equal? 36. If you don't believe me, you are welcome to work it out. I know you guys are probably annoyed with me with how much we're working them out anyways, so I'm guessing it won't matter. It won't matter if we skip that. Okay, so what is the relationship between the answers to A and B? They're the same. State the obvious, right? Why is this true?
Because there's a property that says,
It's like a reflexive property or something.
yeah, it's like no matter what you multiply,
Yeah.
what goes first, it's always the same.
Okay. Essentially, the denominators are the same, right? Okay. With that, and it has to do with 2 plus 7, those second numbers are, I don't know what the word is I want to use, but they add up to be 9. Okay, 2 and 7 is a sum, has a sum of 9. And so if that's true, that's going to give us the same answers here. So, A and B have these same answers. And I'm just going to state that their denominators end up the same. Okay. We practiced a lot of permutations yesterday. Permutations, order matters. We practiced some combinations today. Order does not matter. Now, pulling it all together. Being able to look at a scenario and pick which is which. Okay? So, this question here, do the possible outcomes represent permutations or combinations? So we're not finding the actual answer here. We just want to know, is this a permutation or combination? Okay, in other words, does order matter or does order not matter? That's the big thing here. Okay, so Jennifer will invite 3 of her 10 friends to a concert. Does order matter? No. Does it matter which order she invites those 3 friends? No, it just matters, are you one of the 3 friends that got invited, right? That's essentially what matters. Okay, so this is a scenario where I'm going to say order does not matter. It didn't say we were trying to arrange her friends in groups or anything. And so this is a combination. B. Jennifer must decide how she and her 3 friends will sit at the concert. Okay, so she's taking her and her 3 friends, 4 people, and she is arranging them. And so order matters, isn't it? Otherwise, if we're just picking 4 people to put in 4 seats and order doesn't matter, there's just one option. But this is a matter of you're taking these items and you're arranging them. Who's in the first seat, the second seat, the third seat, the fourth seat. Oh, now we're going to mix them up. Now here's a different order. Okay, so this is one that is a permutation. And it's a permutation because order does matter. Okay. Sometimes you'll be asked to find the amount, sometimes you won't. Here, you can tell if nothing else by the little room I left, there's no numbers involved. Now, I guess I didn't put directions on this section, but we're answering the questions. Okay? So, how many different ways can a 4-person team be chosen from a group of 8 people?
They said they have to be in a certain order.
Okay. It's how many different ways can a 4-person team be chosen from a group of 8 people? So if I have 8 people standing in front of me, you're picking it doesn't say anything about ordering or ranking. It just says picking a 4-person team. So is order going to matter? No. So that means we're going to do a what? A combination. Okay. A combination of how many people we're picking from?
8.
How many slots are we trying to fill? 4. Are you with me on this setup? I feel like I could have left a little bit more room here. Sorry. Right small. Okay, what goes on top for a combination? Well, combination or permutation, what goes on top?
Big number.
Bigger number, 8 factorial. Denominator. You've got the 4 factorial, because you start with r factorial, and then n minus r, so 8 minus 4 factorial. So clean it up on top, 8 factorial, and on bottom, 4 factorial times 4 factorial. Okay, do some math. 8 factorial means 8, 7, 6, 5, 4, 3, 2, 1. Denominator, 4 factorial, 4, 3, 2, 1. Another 4 factorial, 4, 3, 2, 1. Are you guys practicing doing some of this canceling on your own? Are you getting the hang of it? I see a 4, 3, 2, 1. Cancels with a 4, 3, 2, 1. What else did you want to cancel?
1, 2, 4, 5, cancel 8.
Okay, so Logan sees 4 times 2 is 8. Now, could you have been different and could you have done 2 times 3 is 6? And then you have the 4 left over still, right? To each their own, it doesn't matter. What else do I have to do now the way this is? Yeah, the 3 divides into 6. 3 divided by 3 is 1. 6 divided by 3 becomes 2. So the way mine reads, I see 7 times 5 times 2. 7 times 5 is 35. 2 times 35 is 70. Ultimately, it matters. Did you end up with the same answer? Okay. Next one. How many ways can 12 runners in a race finish first, second, and third? Is it obvious? Sometimes they're not obvious, but this one, if they're asking you how many ways can they finish first, second, and third, it matters whether you finish first, second, or third, doesn't it? Did you finish first and get that, lead spot, or did you fall behind and finish in second, right? So it matters. Order matters. So this is a permutation.
Be careful what it is.
In terms of,
I mean, there's only 3 spots. I'm just gonna do that.
oh, I see what you're saying.
The equation.
I see what you're saying. No, I don't. Okay. Now, with that being said, okay, first of all, what are we picking here? 12 for 3 spots. Okay. Do you know how to set the formula up?
Yes.
Because that is an expectation. You do have to be able to set it up. Now, do I necessarily care if you set this formula up in this case, or what's the other option? How many blanks are you trying to fill? I was going to set the formula up, but we're trying to fill in 3 blanks. Do you remember talking about this yesterday? You can use this for permutations. How many options for the first spot? 12. Someone finishes first. How many options for the second spot? Somebody finished the second. How many options for the third spot? Could you just jump and do that? Yes. Otherwise, if your brain's not going to be able to keep straight, when do I do that? When do I not? Can I not do that? Set up your formula. So either way. So remember now, permutation. We haven't done this since yesterday. On top is still 12 factorial. What's on bottom?
12 minus 3.
Yeah, only the 12 minus 3 factorial. So 12 factorial over 9 factorial. And so here we have what? 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over 9. 9, 8, 7, 6, 5, 4, 3, 2, 1. If you followed the formula, what cancels? 9 through 1, yes? And what am I left with? 12, 11, 10, right? Same thing that if you just set up blanks. And I didn't talk about over here. What is 12 times 11 times 10? Okay. 1,320 options. Seems like a lot. Okay. Okay. One more in this section. This is the wild card. We've had a combination, we've had a permutation. Now there's an extra one. In how many ways can 11 contestants for an award be narrowed down to 3 finalists?
It doesn't say.
Because it doesn't matter who, it's just 3 people.
You just want to be in that group of 3 finalists, don't you? If you just want to be in that group of 3 finalists, you just want to be one of the group. If we just want to be one of the group, if it's a combination. Okay? So this indeed is a combination of 11 contestants picked for 3 spots. Okay? I see some erasing out there. It takes work, guys. It does. Okay? On top, whether it's a permutation or a combination, on top I'm doing 11 factorial. On bottom, since it's a combination, I have to say r factorial, which is 3 factorial, in addition to n minus r. 11 minus 3 factorial. On top, 11 factorial. On bottom, 3 factorial times 8 factorial. Okay, on top, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. On bottom, 3, 2, 1, and 8, 7, 6, 5, 4, 3, 2, 1. The obvious piece is that, maybe I shouldn't call it obvious, but the 8 through 1 cancels, yes? And, okay, 3 can go with the 9. 3 divided by 3 is 1. 9 divided by 3 becomes 3. 2 can go into 10. 2 divided by 2 is 1. 10 divided by 2 is 5. And I end up with 11 times 5 times 3, which is 165 is what I'm being told. Okay. On the back, we're going to start talking about using probabilities. Okay. How can we use combinations and permutations to do probabilities? Okay. So that's the direction we're going to head here. Now, as we do that, let's look at the first one. A teacher chooses 5 students at random from the names shown to work together on a group project. What is the probability that the 5 students' names begin with a consonant? Here's the deal. In order to do probability, you have to know a total amount, yes? Okay. And then you have to be able to figure out what you're looking at on top. With this amount of names, it's hard to just do counting up. And so this is where we can use our permutations and combinations. Now, choosing 5 students at random to work together on a project, is order going to matter? No, we're choosing 5 students. It just is a matter of when do you get chosen? Do you get chosen? So I am going to comment for the record that I'm going to think in terms of combinations. Now, we're asking what is probably that 5 students' names begin with a consonant. Okay, let's do some data gathering here. What do we have in the way of names over here? Have you counted? How many names are we at? 18 names? Okay. I'm just organizing. 18 names. Of those names, we're going to have to know how many begin begin with a consonant. What's a consonant?
Opposite.
Opposite of vowels, right? So not A, E, I, O, U. How many begin with consonants? What was it? 13? So 13 begin with consonants. While we're here and in the counting mode, well, yeah, we'll come back and get it later. Okay, so that's what we need for this first one here. The question is, probably 5 students' names begin with a consonant. Okay? When we look at how many combinations there are, out of all the names, we would be picking from 18, yes? And so in our denominator, we're going to look at the combination of picking from all 18 names, but how many are we trying to pick? We're trying to pick 5 at a time. So 8 combination 15 will tell me how many groups, if I'm picking from all 18 students, how many groups of 5 I could make. Okay, keeping in mind denominator is all possible outcomes, right? So how many groups of 5 are there? Now, the numerator is, okay, what's the favorable outcome here? We're being asked the probability that the 5 students' names begin with a consonant. How many names, you're still picking a group of 5, but how many names are you picking from if you're only picking from names that begin with consonants? 13. So that means on top, we're going to do 13C5. Okay. A, I'm running out of time. B, that's a lot of extra work if we're going to work both of those out by hand, isn't it? Good opportunity to learn the calculator real quick. Even then, I'm really running out of time. I'm not sure where my time went today. Okay. If you use my calculator, or this calculator, or any calculator, you're looking for a probability button. I have my PRB button here. When I hit PRB, notice I get NPR as an option, I get NCR as an option, and I get a factorial as an option, yes? Okay, now, I should have hit a number in first. If I'm doing the top, I need to do 13C5, yes? Because if I recall correctly, I have to put the number in first, yep, okay. So, if I'm doing 13C5, clear your calculator, type in 13, go to the probability menu. I want NCR, so I'm going to arrow to the right, hit enter. Notice it says 13, NCR, what's my second number? 5. Hit enter. What do we get? 1,287. If you have a different calculator, you have a combination button on there somewhere. Work to find it. Okay? It is on there. Work to find it. Now, here's you know what the answer is supposed to be, yes? So you'll know if you get it right or not. Paul. On the far left, hit the math menu button. Arrow over like 4 menus to the right. Does that make sense? The rest of you, did you do 18C5?
Yeah.
Do 18C5, get that number, divide, you've got an answer. So math menu, this has a lot of crap in it, okay? If you arrow over, 1, 2, 3, okay, 3. There's your NPR, NCR, and I don't remember on this, probably. Okay, you can just put your numbers in now. Okay? Hit me up later if I need to look at your calculator. I will help you figure it out. What do we get for the bottom?
8,568.
Okay. Is your calculator working if you figured it out? Okay, I just answer as a decimal and then as a percent. So as a decimal, 0.15021, which is approximately what percent? 15%. Okay. Now, change this one up. Probability that 5 students' names end with a vowel. What are we doing here? On bottom, 18C5, because we're picking what's the total possible outcomes. Picking from all 18 students to fill 5 spots. On top, we never counted, did we? I'm hearing 12 end with a vowel. So, if 12 end with a vowel, that means on top you're picking from 12 students to arrange 5 at a time. Not arrange, to choose 5 at a time. I know my denominator is 8,568. Numerator is 792. For whatever reason, I have this decimal place, I have this decimal now, or this percent to 2 decimal places. I am not consistent. Oof. 0.09243, which is approximately 9%. I would take it. You guys know, watch Savas. I have 9.24% written on my answer. Okay. A company. I still got a couple minutes. Don't shut down on me yet. A company wants to form a committee of 4 people from its 12 employees. How can you use combinations, I love it when they're helpful, to find the probability that the 4 people newest to the company will be selected? Okay. Let's start with on bottom. There's how many total employees? 12. And you're trying to pick how many? 4. So are you with me where we're talking 12C4? Now, on top, probably the 4 newest people newest to the company will be selected. How many people are we picking from? 4 to fill how many slots? 4. So this is going to be 4C4. I know a little something. If it's a combination, the numbers are the same. 4C4 ends up being 1. Have you done the math? 12C4 is 495. I left my answer as a fraction here. You know. I feel inconsistent like Savas, I guess. The next section, students will be chosen at random for school spirit awards. There's 6 athletes, 8 non-athletes who are eligible for 2 possible prizes. What is each probability? Okay, again, they're eligible for 2 possible prizes. Does it talk about which prize is which and ordering them? No. So you would be looking at combinations, doing a similar thing here. Okay, and the bottom one we didn't get to. I think the bottom one could be done with combinations or permutations, if I recall. But, huh? No, you still need to get the homework done. I am on limited number of days left in this school year. Okay. Have I shown you some probability problems? Yes. Can you ask tomorrow in class about some probability problems if I didn't help you enough? Most definitely. Okay. So, yes, homework is out there. It is available. It is still due tomorrow. Okay. We will have some time in questions in class if you need to ask questions. However, I would encourage you to try and get the homework done today as opposed to waiting until tomorrow, because otherwise you're missing out on time to work on the worksheet tomorrow. We need to get the we need to get going on the worksheet. If you are not here tomorrow, see me about grabbing a worksheet before you leave so that you're not behind.